Okay, so we are going to do a quick tutorial on how to remember how to use our transformation of the parent function to write the equation of a parabola. The reason why I want to use the transformation form, I still think it is the easiest way to build the equation, and it actually is kind of what we've been doing with the ellipse as well. This is what we're going to be doing with the hyperbola. So I want to kind of stick to this way of writing the equation, because technically right now we are given, if you look at the graph here, we are given the x-intercepts right here. So we could potentially write the equation of the parabola using the x-intercepts in factored form and solve for solve for the scale factor. We could also do it in vertex form. But I want to focus on writing it using a transformation, so we just can match the other conic sections that we're going to work with. But just know this is something you could do if you get confused or if you forget how to do it. This is something you can always go to that. Okay, so we just now have to remember our parent function of our parabola, which is y equals x squared, right? Again, like we did with our ellipse, remember the first thing you always write, and especially for the parabola, it's not so important for the ellipse, because since you are usually kind of setting up your equation like this first, right? You know that the translation goes here, right? And you know the A and B are your dilations. You don't really have to worry about that. But I don't know if you recall from the unit we did on parabolas, the order actually matters in this sense, because we need, and especially for the parabola, because you need to always put your dilations under, including as a division, including your horizontal and vertical shift or translation. Okay, so we're going to start this way. We're going to look at the vertex. Remember, the point of reference, our point of reference of our parabola is always going to be our vertex. It moved 1 unit to the left and 3 units up. So we're going to also try to focus to leave our vertical shift and dilations and reflection with the y, and a horizontal shift, dilations, or reflection. In this case, there's no reflection, with the x. Okay, anything horizontal with the x, anything vertical with the y. So it's moving 1 unit to the left. So remember, you are inserting it, opening a parenthesis. So we're going to put +1, remember? And our y minus 3. We are changing our signs. Okay, it's moving 3 units up, so we put -3. It's moving 1 unit to the left, so we put +1. Good. Now let's look at our dilation. Now this is always going to be, it's always the trickiest part, I think, of the parabola is finding your dilation. I think in this case it's going to be pretty simple. I made it very simple. First of all, did you notice that the parabola has a vertical reflection? So I know that my vertical dilation will have a negative in front of it. So just don't forget that. Remember, the reflections and dilations can be placed together. Now you just start traveling. You see here, there's 1 unit this way. It is not on the corner. It's like somewhere in the middle here. So we know this is not the first dilation. So it's not 1, 1. So let's travel here another unit. 2 units here. Do you see any corner catching here? Yes, look. So we have a 3 units here and 2 units here. So we have a dilation by a factor of 2 horizontally. So let's rewrite this. X plus 1, I change color, over 2 square equals, and now I know I have y minus 3. And then don't forget, it's a vertical dilation by a factor of 3, but it's also a vertical reflection, like a reflection about the about the x-axis, but it's a vertical reflection. So we're going to put our minus 3 here. So this is the final answer for this equation. My equation is y minus 3 because it moved 3 units up, over -3 because I have a vertical dilation by a factor of 3, and I put a minus because it is reflected, right? Vertically reflected. Then it's moving 1 unit to the left. So we are putting x plus 3, and there is a horizontal dilation by a factor of 2. Okay, so I hope you can remember this. Also, quickly, remember that if your parabola has something called a focus somewhere, always inside, always inside, and the same distance, on the other side, there's something called the directrix. So our next video will be talking about that. But before we can do that, I'm going to send you write equations before. Okay, so I'm going to send you to the book to write some equations of parabolas first, and then you will disregard the part of the question where it says to find the focus and the directrix. Okay, I want you to be able to write the equation in transformational form. Then after you watch the next video, you'll be able to go back to those exact equations that you wrote, and you'll be able to find those new components, okay? Parabola, if my parabola is, I'm just gonna put it quickly here. If my parabola is, okay, if my parabola is facing this way or this way, right? You are gonna get now x equals y squared. I don't know if you guys remember that. This is as valid. You just have to insert, and careful, anything that's horizontal will go with the x, and anything that's vertical will go with the y. Nothing changes, okay? It is just a parabola the other way around. We've learned that in chapter 3, okay? So you will get to review those particular parabolas in this section 8.3 in your book, okay? I hope this review helps. So what I'll do after this video, I will have you write a few equations just to practice, and then we will dive into our new components of your parabola. The new components is just your parabola. Should go back to the parabola.